So welcome back. So in previous lecture we discussed about the terraces, and now let's see further how we can differentiate between the gradational terrace and depositional terrace or degradational terraces, and what are the name of the terraces or terminology used for the such surfaces formed when there is an incision in the sediment succession as well as the bedrock. So, this is another example from the same river basin where you can clearly see two terraces. One is here and another one is this place here, okay, and then third one is sitting somewhere over here. So, you have T0, you have this T1 and then T2. So, at least three terraces you can mark here easily. So, we will see that how these terraces are formed and what are the reasons for that. Okay. So, terminologies which have been used, which we discussed, is basically we will have an erosional scarp along the bank of any river, and that having a flat surface will say that or term that as an terrace. Okay. So, this we have also discussed in one of the slides. So, I will just move ahead. So, these are all abundant terraces or the floodplains, older floodplains, and this portion is marking the present floodplain area. This portion we have already discussed, so we will go ahead. Now, fluvial terraces also known as river or alluvial terraces, because again they are comprised of the loose material comprising of or made up of gravel to clay size particles, okay, formed due to incision or cutting into the alluvium or bedrock. Incision occurs as a result of change in base level. So, this is what I was talking about, that if there is sudden change in the base level, then so the base level could be your ocean or could be your mountain front. So, these are the two which we should take into consideration when we are talking about the base level. So, if suppose channel is coming and debouching into any major river or at the ocean, and if there is a change in the base level here, so this channel will try to incise, okay. And if there is a local change, then also it will result into. So, suppose there is a change here, then it will incise this portion. So, let us see what the factors which are responsible for the change in base level. So, change in sea level is also considered as a change in the base level of any major drainage system, okay, caused by tectonic uplift or subsidence. Change in the discharge conditions, that also will affect the base level. If there is an excess deposition, that will also result into the change in the gradient or will elevate the channel floor. And further, the classification of terraces we can have in two forms, that is, one is your erosional. Of course, this in general we talk this as an erosional feature, but we can have the erosional terraces are those cut into the bedrock, also termed as strut terraces, and then we have depositional terraces are those cut, okay, into previously deposited alluvium. So, in both the cases we have the incision, okay. So, you have the either it is an erosional terrace or we are talking about the depositional terrace. In both the cases, this landform is formed due to incision. So, this is the important part here, and the incision can be resulted because of the change in the base level. So, the change in the base level could be your change in the sea level, due to tectonic uplift or subsidence or due to change in the discharge conditions. So, let us see example of strut terrace in coming slides. Okay. And before that, the most common in the floodplain areas, what we see is the lateral migration of the river banks or the river channels. Okay. So, this is a typical profile of the meandering channel, where this portion is deeper, this is shallower here. So, this portion has the capability of erosion, whereas this portion will show you mostly the deposition. And since it has a capability of eroding here, this will keep moving laterally in this direction, and this portion will also keep moving laterally in this direction along the channel. So, you have the, so for example, you have the first channel which was flowing here. Okay. The next phase maybe possibly it will move further this side here. Okay. So, it will keep changing its course because of its tendency to erode. Okay. So, you will have the lateral shift from here as well as from here. Then we have erosional terraces, which are, so these are the features which have been termed as point bars. So, point bars usually if we take the cross section here or the channel forms here, so mostly you will find the deposits are here and they are termed as. So, if you see in the plan view, and this is the cross section which has been shown here, or if I put exactly the cross section which has been shown here, then you will have something like this. Okay. So, you have coming like that. Okay. So, you have one point bar here and you have the erosional bank that side. Okay. So, if I put here B and A, then this is your A and B here. So, you will see very much exactly. So, this portion will have high energy conditions, this will have low. So, this will be the erosional bank, this will be the depositional bank. So, further the erosional terraces. So, if we have the incision in the alluvium and bedrock, and if we see this in section here, okay. So, we see in the exposed section, so this is the present day channel. So, if we see this, then we term this as an erosional terrace or strut terrace. So, let us see this example in Himalayas. Okay. So, this is a photograph which we took from one of the channel or close to the mountain front over here. So, what we see is the terrace here. So, photograph has been taken from here, looking at this terrace here, and this is your mountain front. Okay. So, we have the scarp here that we will talk later. So, this is a fault scarp here, and then we have the terrace which have been marked here. So, two terraces. Okay. So, we have the T2 here, the higher one, and then T1 is this one. Okay. So, T1 and this one is T2, or you can also say that this is T0 and T1. Okay. Now, what we saw is that we have the incision in the younger quaternary channel fill deposit, as well as the channel has inside the bedrock, that is your upper Shivalik. Hence, this terrace we term this as an strut terrace. Okay. And this is the sketch of this one. So, what we see is the terrace over here. Okay. So, this has been marked as this one here. Okay. So, you have the scarp here. So, this scarp is along the fault line. So, this terrace has been displaced along the fault and it's been uplifted. Okay. And then you have another terrace which is sitting over here. This one is the older terrace. Okay. So, you have T1 here and this is T2, and since we were able to see the terraces on either side of the bank, such terraces are being termed as paired terraces. So, if we take the cross section here, or maybe like that, okay, then what you see is you have paired terraces. So you have T2 here and T1, T1 and T2. So these are typical of the paired terraces, and since it has the younger one, the T1 has incised into the bedrock, hence we will term this as an strat terrace. Now such features are important for us to talk about the tectonic activity, because and since it is close to the front. Okay, so this if such terraces are been identified, then they are almost a direct indication of a tectonic uplift along the front. And if we suppose take the cross section here across this line, then what we see is that you are having the front here, and then you are having the displacement. So this is the, so if I draw this in 3D, then you will find something like this. Okay. So you have an scarp here, and this is the fault which passes through. So this is an uplifted part moved up along the thrust fault. Depositional terrace. Now what is the difference here is that it is not the section which you see here, it only shows the incision in the alluvium. So its own, so this is your river channel, and the incision what we see is within the alluvium. Hence such terraces are been termed as depositional terraces. So the most important feature that what I was trying to identify tell you is that we need to identify even the displaced terraces, which has been shown here. This photograph is from Pakistan, where the 2005 Muzaffarabad earthquake rupture took place, and the portion which you see here is nothing to do with the erosion related to the river by river, but it is because of the uplift here. Okay, so this portion is up with respect to this one. So this is your footwall, and this is your hanging wall, and fault runs somewhere over at the base here. So similarly, what we use, how we use this information is that we try to map and prepare a detailed geomorphic map where we highlight the different level of terraces or the surfaces, not only the terraces but also alluvial fan surfaces, because the alluvial fan surfaces will be commonly seen along the base of the front, that is your Piedmont zone, and as well as the formation of the terraces here. So if the multiple terraces are been displaced along any given fault line, then that indicates that that fault has remained active since long. Okay, so this satellite photograph is from northwest Himalaya, where we have the Chandigarh city sitting in the Indo-Gangetic plain, and then comes to the, we have towards north, if you move, we have Upper Shivaliks and Pinjore Doon, that is the intermountain valley between two hill ranges. So we have, this is the tertiary hills or the tertiary lower tertiary or lower Shivalik hills we have. So in between we have the intermountain valley. So again, this is a very flat region where we see the alluvial fan deposits, and then we also see multiple terraces. So viewing this in 3 dimension using the high resolution satellite photo with stereo vision, we prepared this map which shows, so what we have extracted drainage, we have extracted the landforms here, and more striking one what we will see here is that this portion, okay, which has been marked here, the right bank of Gaggar river, it shows presence of multiple terraces. So at least what we have to, if you see the yellow one here, you have the younger terrace, then you have another terrace which has been named as Kaushalya terrace, Pinjore terrace, Kalka and Gaggar. So you have at least 1, 2, 3, 4 and 5 terraces here, and in between we have the Pinjore terrace, which was further classified as an middle terrace and higher terrace in this region. Okay. Now what important point to be noted here was that the fault has displaced all these terraces, okay, including the younger one also, not this youngest one, but at least somewhere over here it has displaced the. So all 5 terraces were been displaced along this, whereas the Pinjore Garden fault has displaced the older terrace, that is your Gaggar terrace, which is the older one, as well as the younger and the Pinjore terrace, which is the third, which is listed here. Now, if we date this terraces or this surfaces, then we will be able to talk about that when exactly this event was took place, or when this event took place, or at least we will be able to bracket the event between having the age of the older terrace and the younger terrace. So that we can do and correlate that what we call the tectonic geomorphology with the paleoseismic studies. So basic map is extremely important to be prepared before we get into the paleoseismic studies and have the understanding of different landforms. That is extremely important. So that what we do before we get into the field and start doing our hunting for the paleo earthquake signatures. So now if we look at this, other than that the terraces, what we try to identify that how the surfaces are been deformed. For example, if you see here in this map, we have some arrows which are been indicated with the different symbols, okay, where we have double arrows. So this are indicating a sort of a warping here. This shows the tilting on the opposite side. That is, usually we find that the fan surfaces from the hilly areas towards the plain will be sloping in this direction, but this is sloping in the opposite direction. So these are again an indicators of the tectonic movement which resulted into the back tilting. So if you have usually the alluvial fans, then from here if I put the topography, then you will have something like this. Okay, so the slope will be in this direction, but what we see here is that at some locations, for example, this portion, okay, so this portion is showing the tilting in this direction. So if I take the section here, then it looks something like that. Okay, so it has a back tilting. Okay, so these have been termed as back tilting scarps, and the signatures or the which we found here was the scarps or the escarpments along this line, and that is what your fault line is, and they are back tilted here. Okay. So next photograph I will show from this portion where we mark the back tilting here, as well as the echelon falls which we picked up, which displays the Pinjore surface. Okay. So this is the photograph from there, this region, and this shows the portion of the back tilt. So this comes over here. This is the portion here at Mandala, and these are the features which you can see over here. Okay, so the arrows mark that. So the back tilting which comes here is a Mandala, then Raru and Dora. So you have the echelon faults here. So the typical like this you will be able to see very prominently when you see the image in 3 dimension, but the tonal variations also helps us in identifying, because there is a dark portion here which shows that there is a cliff here, and similarly over here also. So we have this and back tilt here. So if you see in the field what we were able to pick up. So the photograph was taken from this portion, viewing that side, not exactly this one, from here. Okay, photograph was taken from this bank, and we are seeing this portion here. So the next photograph which you see is the topography along this line from the ground to this one here. So we have this one. So this is east and this is west. So you see topography and typical. So this portion we term this as a fault scarp. And this one is what the feature will take into consideration is the back tilting. So the general slope should have been something like that, okay. But what we see is this portion is uplifted here and then back tilted. Okay. So this is the scarp profile. So this will be your fault scarp, and this is your back tilting. So if you date this surface, then you will be able to talk about then when exactly this event took place. Okay. Again another one along the Pinjore Valley itself. So you have the fault scarp. The fault is running here. So this has been termed as fault scarp, and you can see this one here is the back tilt. And this is typical of the feature which has been formed along the low angle for thrust faults. Okay, so you have you'll have the formation of the fault scarps here and then back tilting. Now coming to another one part which is again an important one, which we are talking about, that is, one is the base level change, and also the formation of the river terraces, and where the sediment supply will also play an important role. So this schematic diagram represents the threshold of critical power, and as well as a balance between erosion and resisting forces. So what it shows here is that you have the sediment size and which increase and decreases here, and as the sediment size increases, so you have more resisting power because of the internal friction between the sediments, and that will result into the degradation and also increase in the bed load. Okay. Whereas here, if you talk about the slope, stream slope, then if you are steepening the slope, then you are increasing or decreasing the stream power. Okay. So increasing in the sediment size and the slope correlation. So this steepening of the stream slope will result into degradation. Okay. Now with this, let's see that how different terraces can be classified here, where we can term this terraces either they are erosional terrace or degradational terrace. And as we discussed that if the terraces are formed cutting its own deposits, then we term that as a degradational terrace, and if the terraces which are formed cutting the bedrock, then we term that as an degradation terrace, or we can also call as an strat terraces. Now it is well established that the change in the stream power affects the fluvial process, that is either the river aggrade or degrade. Along with stream power, other factors, okay, which will be playing an important role is the sediment load, then you have stream capacity to carry the sediments, and then roughness. This is what we are talking about, the resistive nature of the river bed. Okay, and that will also influence the gradation and degradation process. Okay. Now if a river neither aggrade nor degrade, then it is considered to be in a state of equilibrium. Otherwise, if it erodes or deposit, then it is not exactly in the equilibrium condition. So any change in the basin, and which is related to your base level, then it will try to come back into the equilibrium state. So increase in the slope of the river plus increase in discharge plus decrease in river bed roughness plus decrease in sediment load will like result into river to erode, okay. Whereas decrease in slope of the river, decrease in discharge, and increase in river bed roughness plus increase in sediment load, a river will grade, okay. So this part you should keep in mind when we talk about the whether the river is in a gradational phase or river it is in degradational phase, okay. So this is a degradation, and this is what we are calling as an gradational phase. So what we see here is the gradational terraces, okay. So mostly we look at the terraces which are been cut and fill, okay. So a river grade and then degrade. So this all terraces which have been formed in its own alluvium or after because of the incision in its own alluvium, these have been termed as gradational terraces, okay. But when we see that the terraces are been formed cutting the deposits as well as the bedrock, then we term this as an degradational terraces, and they are also been termed as start terraces, okay. So usually what we will see is the on the bedrock you will find along the cliff you will find some fluvial deposits which are also the part of that terrace, okay. Then we have the paired terraces, as we have discussed about this, and unpaired terraces will not have the systematic profile on either side, okay. So now in case of the gradational and degradational terrace, if we take here, now if you classify this, what we see here is that these are all the gradational terraces, okay. These are all gradational terraces, and these are also gradational terraces which we were looking at here, okay. But this portion is your degradational terrace, whereas this one is the gradational terrace. Now how we will be able to differentiate, even though this we can see that this has been incised in its own alluvium, but this was the phase of a gradation 1, this was the phase of a gradation 2, and this was the phase of a gradation 3, okay. So what happened was that the first incision which took place here was this one, hence this we will term this as an gradational terrace, whereas this part was later on. So it was not, but that is a process where we see the cut and fill, okay. So first graded and degraded was this one only, but then we had a phase of degradation, hence this terraces are been termed as or categorized as in degradation terraces. So I'll stop here and we'll continue in the next lecture. Thank you so much.